All right, Algebra 1B, this is day 3 of motion problems. This problem set that I have here is your exact same problem set. I'm going to do the 3 odds and you guys are assigned the evens. So let's just dive right in here. Question 3 says, in Blue River, Terry can row 36 kilometers downstream in 3 hours, but it takes him 6 hours to row upstream. Now, in case you didn't know, if you're going downstream, you're going with the current. And when you're going upstream, you are moving against the current. All right, so our job is to find the rate in which he rows in Stillwater and the rate of the current. Now remember, we use exclusively the distance equals rate multiplied by the time formula. So you just need to assign stuff to our 3 variables and work from there. So my first set is going to be the downstream one, and then my second equation is going to be the upstream. Now, according to this description, the distance is 36. And it's going to be the same distance going back. And now here's where you want to watch how you set up. So we need to find something that represents the rate in this, and that's going to look like so. I'm going to bring in 2 variables, and they're going to be labeled as such. X is going to be his speed in Stillwater, and y is going to be the speed of the current. So when he's going downstream, he's working with the current, so that's a plus on his side. And it says in the problem description that it took him 3 hours. Now when he goes upstream, he's rowing that same speed in Stillwater, but he's also working against the current, so it's taking away from his momentum. So it's going to be minus that. And it took him 6 hours. It took him twice as long to get back that same 36 kilometers. So our question is to figure out, well, how fast does he row in Stillwater? And what is the current of, or what is the speed of the current? All right, now here's my process for this one. There's a couple different ways you can solve it, but we're just going to use one exclusively for this. What I'm going to do is I'm going to divide the distance by the rate in order to make a simplified equation. So it's going to be 36 divided by 3, and that is 12. Now that's going to equal his speed plus the current. And we're going to do the same thing for the second one. We're going to take distance divided by the time, and that's going to be 6, and that equals his speed minus the current. Now we want to use what we were working with about a week and a half ago. We want to use what's known as the elimination method when you're solving a system of equations. Unfortunately for us, we already have opposite coefficients in one of our variables, so we simply need to add them vertically. So 12 plus 6 is 18, x plus x is 2x, and these are eliminated because 1 plus a negative 1 is 0. Now our second to the last step is to solve for his speed in Stillwater, so 18 divided by 2, and that is 9. So his speed in Stillwater is 9 kilometers per hour. Now you want to choose one of these two in order to back substitute your value for x to solve for the current speed. And for this situation, they're both about the same difficulty. I'm just going to plug in 9 here. 9 plus what is 12? Well, that's simple. That's 3. So he goes 9 kilometers per hour in Stillwater, and the current speed is 3 kilometers per hour. All done. All right, number 5. Joe flew a small airplane 900 kilometers in 5 hours with the wind. And then he flew 700 kilometers against the wind in 7 hours. Find the rate at which he flies in still air and the rate of the wind. Okay? I'll just do this one right on this page here. So I'm going to say my first one is going to be with the wind, and the second one is going to be against wind. So distance equals, now this one's going to be the same type of setup, except we have a different scenario. We're not dealing with water and rowing, we're dealing with the plane speed and wind. So x is going to equal plane speed, and y is going to equal wind speed. So when he goes with the wind, just like the current one, it's helping him out, so it's a plus, and it took him a time of 5 hours. For the against one, it's 700 x minus y, and it took him 7 hours. Now, like we did on the rowing one, we're going to take the distance and we're going to divide it by the time. So 900 divided by 5 is 180. And now that equals x plus y. Then 700 divided by 7 is 100, and that equals x minus y. And then we use the elimination method, add vertically. 180 plus 100 is 280. X plus x is 2x. And then the y's disappear. Second to last step is take 280 and divide it in half by 2. So that means the speed of his plane is 140 kilometers per hour. And now you can choose which one to substitute x in here for. I'm going to substitute it into the first one. So 140 plus what equals 180. That tells me that the speed of the wind is 40 kilometers per hour. All done for that one. Okay, last example, number 7. A jetliner flying east with the wind, this is going to be our plus one, traveled 3,600 kilometers in 6 hours. So I'm going to say with the wind, I'll write that one right away. So distance equals plane speed plus the wind in 6 hours. And then the second sentence says the return trip flying against the wind took 8 hours. So against the wind, we should probably assume that the return trip was the same distance. And then that equals x minus y, but it took him 8 hours. And like the two previous examples, we take the distance and divide it by the time. So 3,600 divided by 6 is 600. That equals plane speed plus the wind speed. 3,600 divided by 8 is 450. And that equals plane speed minus wind speed. Now we add vertically. So it would be 1,050 equals 2x. Divide that in half to solve for the wind or plane speed, and the plane speed is 525 kilometers per hour. And I'm going to choose to substitute it into this first one. So 525 plus what is 600. That means the speed of the wind is 75 kilometers per hour. Please let me know if you have any questions on these guys. Thank you.